Hello everybody. In this section we're talking about the second day of trigonometric functions. You want to go ahead and copy down the title, put today's date. You don't have to worry about name. Go ahead and write down the directions here, all of the highlighted. Write down example 1A and then go ahead and draw the X and Y axis. You probably want it to be about 2 inches by 2 inches, so it doesn't have to be gigantic on your paper, but long enough so that we can actually draw in a right triangle. So go ahead and pause the video if needed and copy all of this down. So if I read the directions say that a point XY is in the indicated quadrant. So in this case it's in quadrant 2. Decide whether the given ratio is positive or negative, and it says to recall that R is going to equal X squared plus Y squared. The hint is to draw a sketch. So let's go ahead and do that. First of all, I'm going to label 1, 2, 3, and 4. So this is how you always label these coordinate planes. The x-axis is the one that goes horizontally, and the y-axis is your axis that is vertical. The next thing that I'm going to do is I'm put a point in the quadrant that's given. So in this case, I'm going to put a point somewhere in quadrant 2. It doesn't matter where you put it, just make sure it's somewhere in quadrant 2. What this represents is an angle that starts here, this is called the initial side, and rotates around counterclockwise and ends over here at this point. So imagine this is actually passing through the point. My point's kind of a little off there. All right, so something like that. All right, now what I can do is I can figure out what are some attributes, some information about this angle. And I can do that by dropping a perpendicular towards the x-axis. So what I have now is a triangle, and it's not just any old triangle, it's a right triangle. Let's go ahead and label the sides, and we did this in the last lesson. Okay, so this is the x-axis, so this is side X. Find the hypotenuse, that's going to be side R, and then the other side would be side Y. What we're doing in this question is we are trying to decide whether this given ratio, and that would be this fraction right here, y over x, is positive or negative. So I need to look at each side individually. Let's start with the side y, which is the numerator of this fraction. To get over here, I'm going to the left, but then from this x-axis, side y, I'm moving up. When you move up to go to the point, that's a positive movement. So to get from this x-axis up to this point for side y, that would be positive. Side x, though, to get from the origin over to this spot where I go up, to go this way to the left means I'm moving negative. A positive divided by a negative is a negative, so this ratio would be negative in quadrant 2. So example B, we're looking at quadrant 3 and we're looking again at y over x. So go ahead and pause if needed. So I labeled my quadrants 1, 2, 3, and 4, and it always goes in this order because this is how we graph in trigonometry. That's going to make your positive angle. So I need a point in quadrant 3. It doesn't matter where you put it. And what that really represents is an angle that starts over here in quadrant 1, rotates around, and ends in quadrant 3. This is called the initial side or the starting side. Over here, this is my terminating side, and so the angle would look something like that. Now what I'm going to do is I'm going to drop my perpendicular. Now, when you say drop a perpendicular, it doesn't always mean you're making a line down. And in this case, dropping it would mean I bring it up because it's always going towards that x-axis. Okay, let's label the sides. The side that sits on the x-axis is x. The hypotenuse is always r. And the other side then that's parallel with the y-axis is y. Again, what we're doing here is we're analyzing this ratio, the y over x, and we're trying to decide if it's positive or negative. So let's take a look at it. This time, x moves to the left and y moves down. So if you move down to get to this point, that means you are moving in the negative direction. X, from the origin out to this spot to go down, the x is moving left, so again, it is negative. And a negative divided by a negative will give you a positive. Go ahead and copy down 1C and draw the graph. This time you're putting a point in quadrant 1. If you want to keep labeling them, you certainly can. If you understand what the quadrants are, then you don't have to necessarily label them each time. So this is quadrant 1, and what I'm going to do is put a point anywhere in it. Doesn't matter. What that really represents, though, is an angle that starts here at this initial side, rotates around counterclockwise, and then it's ending at that spot, which is the terminal side. I'm going to drop my perpendicular, and now I'm going to label my sides. Okay, if it's on the x-axis, then that side is x. The hypotenuse, the diagonal side, is r, and the other side is y. Again, we just happen to be looking at y over x. So we're really kind of analyzing it all the way around the coordinate system here. In this one, y goes up. Look at x. X is also moving to the right. To the right and moving up are both going to be positive, but we're starting with y. Okay, so y moves up in this graph to get up to this point, so that's going to be positive. And x from the origin moves to the right, that's positive. So a positive divided by a positive is still positive. So copy down your last one of this type. Go ahead and put your point in quadrant 3 and see if you can label your triangle. Okay, so far up until this point, all of these three that we looked at were all y over x. And y over x, even though it doesn't really matter yet, this is a tangent ratio, y over x. We talked a little bit about that the last time we met. So y over x. Now this last one is analyzing r over x, which is actually a cosecant ratio. Again, that part doesn't really matter yet, but let's look at what happens now. R is kind of a unique side. R is the hypotenuse, and according to the directions, we get the hypotenuse by taking the leg squared, or x, plus the leg squared, and we take the square root. Anytime you square something, whether that be positive or negative, what happens is that negative times a negative would end up being positive. So this would be a positive number, this would be a positive number. So the R, the hypotenuse, is always going to be positive. Even though it may not seem like it, you may say, oh, but wait, you're going down there to get the r. Right, but if you're taking a number times itself, squaring it, it will always end up with a positive value. So r is always positive. The x, start at the center, move to the left, x will be negative. So r is the only one that can never be negative. R is always positive. Positive divided by negative is negative. In the next examples, you only have to write what's highlighted. So go ahead and pause the video and you're going to write part 2. You're going to write figure 29, which is on page 24. And you can write for each of the 4 points labeled and all of this stuff. And then go ahead and draw the x and y axis. So pause it now and write this down. So probably the main direction that you wrote here was that r equals 1 in this figure. Okay, so we're reproducing the graph in figure 29. You can look at that in your book. It's on page 24. Even though you have an online book, look for the page numbers in the picture and you'll see page 24, figure 29. It says for each of the 4 points labeled in the figure, r equals 1. Without this information, we could not do this question. For each quadrant angle, identify the appropriate values of x, y, and r to find the indicated function value. If it's undefined, say so. We're looking for the sine of 90 degrees. So what we need to do first is draw a 90-degree angle. Always start at this initial side, and you're going to rotate around counterclockwise until you get to 90. So I'm going to rotate around and stop right here. That's going to be my 90-degree angle. Now, the important part here is that we do have a point. All of these examples had a point that we put in the quadrants. Same thing goes here. We're going to have a point on this graph, and according to the directions right here, this has to be given. According to the directions, that point is 1 unit out in either direction. So in our case, it's 1 unit right here, given r equals 1. Without that information, we would not be able to do this problem. So r equals 1. Okay, now if you try to drop that perpendicular, you'll be able to do it in this one, but there's no triangle that's formed. So what we're going to have to do instead is figure out what this point is as an ordered pair. We can do that because we know that the length of it is 1. It's 1 unit up. So think about how these ordered pairs work. The first number tells you how many you've gone left or right. I haven't gone right or left. I just went up. So the first number tells you that you have gone 0 left or right for this point. The second number tells you that you're moving up 1, positive 1. Let's label it. This is your x, this is your y, and you actually already have r. So we're finding x and y and r, we've got it. Let's go ahead and answer this question. We're looking for the sine of 90 degrees. That's what it's asking for here. You may need to look back at yesterday's notes. The last time we met, look at the notes. The sine is the ratio of the y over the r. And this was from the notes that we took last time that we were together. Look at your picture. We have x equals 0. It's right here. Y equals 1. It's right here. And r equals 1. So if we need y over r, all you have to write is 1 over 1. And 1 divided by 1 is 1. So sine at 90 degrees, or the sine of 90 degrees, equals 1. Let's try a second trig function. So go ahead and write this down and make the little graph. Pause if needed. In order to do this question, I'm not going to try to graph negative 540. That would get really confusing. We're not working with negative numbers. So what we can do instead is find an angle that is coterminal to the one that's given. And a coterminal angle was found by simply adding or subtracting a full rotation or a full circle. So I'm going to add 360. A full circle is 360 degrees, so I'm going to add 360 to this. Negative 540 plus 360 is negative 180. My goal is to get an angle that's not negative, so I'm actually going to add again. And you may have to do this several times on some of the questions. So negative 180 plus 360 is 180. If it's a really big positive number, you may have to subtract. So just keep that in mind. There are some like that. So I'm going to graph 180 degrees. Starts over here at this initial side. Rotate straight up would be 90. Rotate over to this side would be 180 degrees. So it's just a line. I run into the same issue. Even if I put my point 1 unit out, and I know that I can do that because you are given that r equals 1. Even with that information, I don't have any way to drop the perpendicular or anything like that. But I can name this point that's 1 unit out. Here's how. I'm going 1 unit to the left, 1 unit to the left, that's -1. And I'm not moving up or down, so that's 0. That means our x and y values are -1 and 0. And I wrote them right here. So I wrote my x here and my y below it. And so now I'm ready. I'm looking for then ultimately the secant of -540 degrees. So I'm going to write that here. And when I write it, you'll notice that I keep the parenthesis around it. That tells the person looking at it that you're not taking the secant -540, you're finding the secant of -540. So I'm going to go ahead and write the ratio. This is not something that I have memorized. You certainly can use your notes. So I'm looking at my chart. The secant of something is the r over the x. We wrote all these ratios down in the last set of notes. So what we're looking for then is 1 over a -1. 1 divided by -1. And again, that was r over the x. 1 divided by -1 is -1. So then your answer is secant of -540 equals 1. You'll notice that when you do the assignment, it's broken into chunks. So the first chunk of the assignment is going to be identifying the positive and the negative of those graphs, so when you draw the picture. The middle part of the assignment, the part that you may struggle with a little bit, is finding these trig function values. So definitely have your notebook in front of you while you're doing these problems. Now, let's take a look at the last part of the notes, and I think you guys will find this one kind of fun. This is more algebra skills. So this was trigonometry and thinking skills. The last part will be using some algebra skills to solve these expressions. So again, all you need to really do here is copy down part 3, write evaluate each expression, see page 25, so you'll be able to open it in your ebook, and copy down 3A and 3B. So go ahead and pause the video now. So we're going to use the trig function values that are given on page 25. So you have to look at your ebook. And we're going to plug them in place of these. So we're going to use the values in place of the trig functions. So here's how this works. This one says tangent 0. So what you do is you find the tangent column, and you find 0. You follow this one over, you follow this one over, or this time you go down, and what you see is your common solution to tangent of 0, which is 0. So you're going to go over here, and you're going to cross out tangent 0 and replace it with its value, which is 0. 6 times the sine at 90. Okay, so now I'm going to go ahead and find the sine of 90 degrees. So I'm going to find sine. I'm going to follow it down until I see 90. Follow that over, and you can see that the sine at 90 degrees is 1. So I'm going to write 1 in my parentheses. Follow your order of operations. So -6 times 1 is -6. You still have 0. 0 minus 6 is equal to -6. So the answer to this question, this first part, will just be -6. So you can see you're using your algebra skills and then plugging in these trig values. Let's try the next one. We've got 4 times the cosecant of 270 plus 3 times the cosine of 180. Okay, so go to cosecant and find 270. So here's 270. I'm going to follow that over until I see cosecant. Here's my cosecant column. Here's 270. So the 2 meet right here at -1. So the cosecant of 270 is going to be -1. Next, I'm going to look up the cosine at 180. So go to the cosine column, find 180, find where those two things meet. If you have your two fingers, you can put them on the page. You can go down here, move over to the right, and you'll see that the two things meet at -1. Go ahead and simplify. 4 times -1 is -4. This would be -3, and get your total, which is -7. The last two have squares and then fourth power. By definition, it says the cotangent squared 90 means you take the cotangent of 90 and square it. So that means I'm going to take the sine of 360 and I'm going to square it. Minus 5 times the cosine 360 and square that. So sine at 360, find sine, find 360. It's going to be 0. Cosine 360 is 1. Go ahead and solve. 0 squared is 0. 1 times 1 is 1. 1 times 5 is 5, but that's a -5. So 0 minus 5 is -5. Try the last one on your own. Pause now and then check your answer in a moment. So if you got 1 as your final answer, you have it correct. These are the assignment problems that go along with this set of notes and examples.